Welcome everyone. In this video we are going to prove the famous Pythagorean theorem. As many of you might be aware, the Pythagorean theorem tells us if we have a right triangle, which means one of the angles is 90 degrees and at most one can be 90 degrees. If we have two angles that are 90 degrees, well then we can't have a triangle anymore, right? Because the interior angles should add up to 180 degrees. And if two are 90, well then there is no room for the other. So this is a right triangle, and I denoted with a triangle and the dot inside of it. Some people don't put the dot inside of the triangle. I do put the dot. This means it's a right angle, a 90 degrees angle. So if we have A, B, and C, these are just names of the sides, then the Pythagorean theorem tells us A squared plus B squared will give you C squared. This is incredibly useful, and it will be hard to find a geometry problem that you don't use this one. So we need to prove this. We can't just go around using this without proving. And I know in my previous videos I used this without proving. One of my early videos in this channel was proving the inverse Pythagorean theorem. And in that I used the Pythagorean theorem, which you can access from the card right now. But anyways, how can we prove the actual Pythagorean theorem? Not the inverse, not this, not that. The theorem itself. Well, I will start by organizing four of these triangles into an interesting shape. So I want to have, maybe I will have it like, let's color code it. So red will stand for A. We will have one side like this, and the green will stand for B. We will have another side like this, and yellow will stand for C. We have like this. We have our triangle. Now, I will draw another triangle. I will actually draw four of them in a particular order, particular shape. I will draw one C like this. And I am going to draw I meant to draw a B, by the way. It's a B, not a C. Excuse me. And I will draw an A like this. Okay, and then I connect them, connect the endpoints so that I have a C. Well, I will do a familiar thing for our last two triangles. I will draw an A like so, and the B like so. Maybe it should do like this, perhaps. Like this. And then let me connect these. Oops, that's looking terrible, but I will make it understandable, I hope. I will draw it like that, and I will have my B as my A, and then my B. Okay, and don't think about this circle. It is just my poor drawing. Trust me. So what I'm argue is we have a square here. C, 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 C. This is a square, I argue, and I should prove that it is a square. How can I know that it is a square? Okay, all four sides are equal, but that is not the only condition for a square. For it to be a square, this shape, for it to be a square, all interior angles should be 90-degree angles. And in fact, that is all we need to make our proof that this is a square. Because look at this. We know if I make this blue angle and this one the gray angle, let's call it, I know that blue and gray angles add up to 90 degrees because the other one is 90 degrees, and 180 degrees minus 90 degrees gives you 90 degrees. So blue was between A and C, which means this angle is the blue angle. And we'll look at the gray angle and see it is between B and C this time. The blue was between A and C, and the gray is between B and C. So that is just going to be this part, right? And since this and this angles, these angles should add up to 180 degrees. If two of them add to 90 degrees, then the last one is a 90-degree angle as well. So we have a shape that have four of its interior angles is 90 degrees. It could be a rectangle, and it is a rectangle, but it is a special kind of rectangle. It is a square because all the sides are equal, and we know all of them are equal because that's how we organized it. We drew our shapes so that all the hypotenuses, all C's would see each other. All C's would see each other. That's nice. So, I mean, okay, this is cool, but how does this help us to prove the Pythagorean theorem? I claim if we consider the areas, we will get somewhere. And also, let's even name these sides. This is A and B. We also have another square, right? With a side of A plus B. It is a square because clearly this angle is 90 degrees. That is how we defined our triangle, and the sides are equal, as we can see. So I claim I want to consider the areas, which will give us a kind of a pathway to prove the Pythagorean theorem. And I want to find the area of this orange square. And you're saying, okay, that is too easy. The area in orange, the area of a square is equal to c squared. And that is the case, my friends. That is why it is very important. Because look at this. Look at this, guys. We have c squared here and c squared in the Pythagorean theorem. If we can somehow find another formula for the area of our square, and if that formula turns out to be a squared plus b squared, well, then we have proven that c squared is equal to a squared plus b squared. Okay? This is why we consider the area. We directly see similarities. We have c squareds on both sides. This is incredibly good. This is perfect. But okay, this is not enough though. This is perfect, but not enough. So what is the area in another terms? How can we express it in other terms? Well, we can say it is going to be the total area of the whole shape, and the total area of the shape will be the area of the big square, which is a plus b squared. Okay, and we are trying to find another formula for the area. It is going to be a plus b squared. We multiplied both sides. Minus, if we subtract these four triangles, this, and this, then we are left with the square. So what is the area of our triangle, of one of them? It is going to be height A times B, the base, divided by 2. What we have 4 of those, right? This is only this one is only the area of one triangle. We have 4 of them, so we just multiply this area by 4. Which means if we open the parentheses in the first term, we have a squared plus 2ab plus b squared, and you can check that this square in fact gives these 3 terms. Minus, if we simplify 4 and 2, we will have minus 2ab. And oh man, look at this. We see that 2ab's cancel. Great. They are gone. I'm too excited. They are cancelled, and we are left with a squared plus b squared. And what was this a formula for? What was a squared plus b squared? Well, this was the formula for the area of the square. This was the formula for the orange area, which we also showed earlier, that is equal to c squared. So as you can see, a squared plus b squared is equal to c squared in this kind of a triangle. So if you square both legs of a right triangle, and if you add their squares, you get the square of the hypotenuse, the side that sees the 90 degrees angle, and this is called the famous Pythagorean theorem. Anyways, I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.